In this class we're going to talk about economics as a science. Now there are similar classes to this elsewhere on the course, and this one could be seen to be in the same vein as the others, but nonetheless it's important and it should be looked at and studied, and it has its own place on the course, so we will be doing it slightly differently. We'll start by talking about Robbins' definition of economics. Now this is a famous definition of economics put forward by Lionel Robbins in the 1930s. The definition is well known right throughout the world, and it's important we are familiar with it. The definition states that economics is a science which studies human behavior as a relationship between ends and scarce means which have alternative uses. So the definition is full of meaning. All of the words indicated in red in this case all have special meaning, and each of them in fact are the subject of separate videos on the course. But here we're going to concentrate on economics as a science, so we're going to deal with the science part and see what we mean by science in this context. So let's look at economics as a science. The most popular form of economics is known as neoclassical economics, and this is the type of economics that's studied right throughout the world at most colleges and universities. This is the type of economics based on supply and demand, but it goes into looking at the use of mathematics in economics and use of very complicated diagrammatic presentations and very strict pieces of analysis and model building. So it's a very almost scientific approach to economics. And this is called neoclassical economics. It's the orthodoxy. This is the way people study economics, and this is what economics is understood to be at most universities and amongst most students. There are alternatives. There's one type of economics called the Austrian economics, and this rejects the use of mathematics and the use of this type of logic. It has a completely different methodology. And of course, more so in the past, but there was also Marxian economics, which was different. So there are different views, but by and large, the orthodoxy, what is mostly taught at universities, is what's known as neoclassical economics. As I said, it uses mathematical techniques to analyze economic relationships. But it also attempts to use the so-called scientific method. Now this is very important, and we need to inquire into what's meant by the scientific method. First of all, the scientific method postulates a relationship between two variables. It states a relationship between two variables. If you like, it believes there is a relationship between two variables, between inflation and unemployment, or between price and demand, or between costs and the amount produced. Whatever it is, there is a relationship. So we postulate a relationship between two variables. We state a relationship between two variables. Then we collect some data, and we analyze this relevant data to determine the relationship. We analyze the data critically. We use very objective tests if we can and analyze the data critically. And then this process leads to generalizations. If we find that every time the price of butter increases, less butter is sold, then it leads to a generalization. We tend to say, well, every time the price of butter increases, less is sold. We've observed it so many times. We've observed it 100 times, and therefore we can generalize. We'll say it happens every time, which is quite a big jump. But that's the way the scientific method leads us. For example, every time the price of petrol rises, less petrol is sold. Now that's our statement. Every time the price of petrol rises, less petrol is sold. Then we go on to say the price of petrol has just increased. Therefore, less petrol will be sold. This is actually based in logic. This is called syllogistic reasoning. It's based on rules set out by Aristotle. It's deductive reasoning. We start from a general proposition. Every time the price of petrol rises, less petrol is sold. Every time. So it's general. And then we state a minor premise, as it's called. We say the price of petrol has just increased. Therefore, our conclusion is less petrol will be sold. And that's what's known as I said, syllogistic reasoning. It's based on what's known as a syllogism in logic. Now, in order to get to the stage of every time the price of petrol rises, less petrol is sold every time, in order to do that, we induce, we go upwards. We look at examples, we look at more examples, and if we find the same situation arising every time, we start to induce. We start to go upwards towards the general. We've observed it once, we've observed it twice, we've observed it 100 times. After a while we think, every time it happens, this is going to happen as well. So we've induced. So we generalize. So we take a statement like, all A is B. Every time the price of petrol increases, that's A, less petrol will be sold, that's B. So we generalize. For example, all A is B. We base this on our experiences and our past observations. We make observations and then we generalize. We try to move up to say every time the price of petrol increases, less petrol will be sold. The greater the number of observations, the more certain we are of the validity of the statement. We call this the principle of enumeration. We're counting up. We're looking at various examples. The more we observe, the more confident we are in the statement, in the generalization. So the principle of enumeration leads to this generalization. Can I just say before we move on to the next step that there are problems with the inductive method. We could say that every swan is white. Well, what if we saw a black swan? Would it be a swan? Would it be a black bird? Would it be something different? And if we did see a black swan, would that mean that we'd have to change the statement from all swans are white to some swans are white, because we found an exception? And when we generalize, exceptions do arise. So we have got a problem. Now let's move to the deductive method. Induction is derived from past observations. So we say all A is B. And we call that our major premise, let's say. We're going to use this idea of a syllogism. So we've based it on our past observations and we've induced that all A is B. Every time the price of petrol rises, less petrol is sold. Every time. We've got that by making observations. We made a lot of observations. We come up with this generalization. Through the principle of enumeration, we've counted up and we said, okay, we'll generalize. Every time the price of petrol rises, less petrol is sold. All A is B. We deduce from our general statement. Our deduction is, if we know that A is true, then we may predict B will happen. So if we say, every time the price of petrol increases, less petrol will be sold. The price of petrol has just increased, therefore less petrol will be sold. So that's our conclusion. So we have a major premise, the generalized one, we have a minor premise, and we have a conclusion. Now there are many confusions, and there certainly is a confusion about language and economics. There are many confusions in what I've just said and what I've just done. And the more you get into looking at the scientific method, the more you will realize that there are many issues in there that I have skimmed over. But nonetheless, this is our introductory talk. Language is a problem. There's also disagreements in economics. There are many disagreements in economics because, in a sense, we haven't clarified the language. Sometimes we argue in economics at cross purpose. I mean a certain thing and somebody else means something else by the same word even. So we have disagreements in economics. And they may arise over confusion about the language. Sometimes we have to have standard definitions. We have to be clear about what we're talking about. Otherwise, we can't move forward. Our disagreements may just linger because we're not clear about the terms we're using. And there are two types of statement that we may identify in particular. The first type is called positive statements. These statements may be tested. They're positive. So any statement which may be tested against the facts is positive. All school children can read and write. Is that positive? Well, yes. Can it be tested? Yes. I mean, there may be limits on what they can read. They may not be able to read very sophisticated books. And they may not be able to write excellent poetry, but they can read and write. So it's a testable statement. The statement is positive. It doesn't have to be affirmative. It could be negative. We could say that no children have 4 heads. Is that testable? Yes, we can go around and count the number of heads that each child has got. We'll find, generally speaking, each child has 1 head. So, it's testable. It's negative, a negative statement, but it's still testable. And we'd say it's a positive statement. Because it's testable, it's a positive statement. It may be tested. Now the second type of statement is called normative statements. These statements cannot be tested. These statements are not subject to testing. The government ought to do something about pollution. That's my belief. It can't be tested. It's my political belief, let's say. We can't test it. It's in my head. It's a belief. It's a normative statement. So, it's not testable. It can't be tested. It's a statement of opinion. And that is our very brief introduction to economics as a science. Some of the issues we've raised in here are very important. Just understanding induction, deduction, the principle of enumeration, positive statements, normative statements, disagreements in economics, and the whole idea of testing statements. That's very important, and it's essential that you go back over this material a few times and understand each of these parts, and preferably do some reading yourself outside of looking at the video, and make your own notes and make sure you're happy and familiar with what's going on here in the video and in this whole area of economics as a science. One last comment here that I mentioned earlier, we're dealing predominantly with neoclassical economics, but I did mention that there was a different tradition called the Austrian tradition. Now they totally disagree with economics as a science. They think that mankind is not amenable to mathematics. We can't look at general principles because we are too variable. We're too unpredictable. And therefore economics cannot be a science. So please bear that in mind. There are economists who totally reject what I've just done, and it is a very controversial and a very big and it's a big area under dispute between economists. But that's all I'm going to deal with here, so let's leave it at that and say thank you for watching.